Today's topic is kinematics. Kinematics is the study of how things move. Let's review for a moment. What is the formula for acceleration? That's right. It's A equals V final minus V initial over delta t. Let's rearrange this formula to solve for V final. Okay, so the first thing we do is we multiply both sides by delta t so that those will cancel out. So on the left we have A delta t is equal to V final minus V initial. Since I'm trying to solve for V final, I need to move the V initial to the other side. So we will add V initial to each side of the equation. Then the V initial on the right hand side cancels out. This leaves me with the equation V final equals V initial plus acceleration times time. This is the first of our 4 kinematics equations. So draw a box around it and label it as equation 1. Now we will use the average velocity formula to find an alternate formula. The average velocity formula is V average equal delta D over delta T. Another way to find the average would be to add the velocities up and divide by how many we have. So we will use V final plus V initial divided by 2. Now we will substitute this into the first formula in place of V average. This gives us V final plus V initial divided by 2 equals delta D over delta T. Now I want to solve this for delta D. So the first step is to multiply by both sides by delta T so that the delta T's cancel out on the left. This leaves me with the equation D equals 1/2 V final plus V initial times delta T. This is our second kinematics formula. Draw a box around it and label it as the second formula. Next, we will use this kinematics formula to find an equation that does not include V final because sometimes we don't know that. So in this equation, we will substitute the first kinematics formula in place of V final. And it will look like this. D is equal to 1/2 V initial plus A delta T plus V initial close parentheses times delta T. The next step is to combine like terms, the V initial. Then the equation will look like this. Now we will distribute what's outside the parentheses, the 1/2 and the delta T, to everything that is inside the parentheses. Once this distribution is complete, the equation will look like this. Delta D is equal to V initial times time plus 1/2 AT squared. This is our third kinematics formula. Draw a box around it and label it. Sometimes we don't know the time, so we need a formula that doesn't include time. To find this, we will combine these two formulas. The first step of that process would be to rearrange this formula to solve for time. To get the t by itself, we first need to subtract V initial from both sides of the equation. Then it will cancel out on the right, and we are left with V final minus V initial equals A delta T. Now to get the t by itself, we need to divide both sides by A. The a's cancel on the right hand side, and we have the formula delta T is equal to V final minus V initial over A. We will now substitute this equation into the second kinematics equation. So that equation becomes delta D equals 1/2 times V final plus V initial, and in place of delta T, I put the rearranged equation that we just talked about, which is V final minus V initial over A. Now I need to simplify this equation. So first I multiply both sides by A, and the A's will cancel on the right. Then I need to get rid of the 1/2 that's on the right, so I multiply both sides by 2. Now my equation looks like this. Not really simplified yet, but we're working toward it. My next step is to multiply these two parentheses together. Your algebra teacher may have taught you how to do this using the FOIL method. Once you've multiplied those two parentheses together, you will have this equation. But we're not done yet. We still need to simplify some more. Add V initial squared to each side so that it will cancel on the right. Then you will have the finalized equation V final squared equals V initial squared plus 2A delta D. This is our fourth kinematics equation. Draw a box around it and label it. Now let's do some examples with all these equations. Write down this question and then we'll go through how to work it. What is the velocity of the car at the bottom of the hill? Start by writing down all of the given information. It says that the acceleration was 0.58 meters per second squared and that he traveled a distance of 152 meters. Since the car was parked, the initial velocity is 0. We are looking for final velocity, so that is our question mark. Now look through the four kinematics equations. Only one of them includes acceleration, displacement, V initial, and V final, and that would be this equation. So write down the equation that you are going to use. Now substitute in all of the values that you know. Use numerical solve on the calculator to find the answer. V final equals 13 meters per second. Draw a box around your answer. Alright, the next part of the question asks, how long did it take for the car to reach the bottom? So write that down and let's do it. The given information is all still the same. The only thing that changed is what I'm looking for, which is time. Go back to the original information to determine what equation to use. You know acceleration, you know displacement, you know initial velocity, and you're looking for time. That's how you decide the formula. Kinematics Formula 3 fits right here. Okay, so again, we plug in all of the values that we know, and the equation will look like this. Since V initial equals 0, 0 times t is 0, so that term will go away. Using numerical solve, put this in your calculator, and you will find that t is equal to 23 seconds. Box your answer. Now write down the second example about Landon entering a tunnel in his car. Always start by writing down the given information. V initial equals 24 meters per second, A equals 2 meters per second, T equals 8 seconds, and V final is our unknown, so it is our question mark. The only equation that has only these four variables is kinematics equation number 1, so that's the one that we will use. V final equal V initial plus acceleration times time. Now plug in what you know, put it in the calculator into numerical solve, and you will see that V final is equal to 40 meters per second. Box your answer and you're done.